Every year, millions of people struggle with wounds that refuse to heal. These are called chronic wounds, and they can cause pain, limit mobility, and even lead to serious complications. But thanks to modern science, we now have innovative solutions that don't just cover wounds, but actually help them heal. One of the most powerful tools is the tissue graft. In today's video, we'll take a deep dive into the biology of wound healing, the stages your body goes through, and how tissue grafts accelerate recovery. Wound healing is a complex biological process that happens in 4 overlapping stages. Hemostasis. This is the body's emergency response. Within minutes of an injury, blood clotting kicks in to stop bleeding and form a protective barrier. Inflammation. White blood cells rush to the site, fighting off bacteria and clearing damaged tissue. This stage often brings redness, swelling, and tenderness. Proliferation. The rebuilding stage. New tissue, blood vessels, and collagen start forming, covering the wound with fresh granulation tissue. Maturation, or remodeling. Finally, the wound strengthens. Collagen reorganizes, the tissue contracts, and the skin regains integrity. When everything works perfectly, wounds close within weeks. But in chronic wounds like diabetic ulcers, venous ulcers, or pressure sores, this process stalls, often in the inflammatory phase. That's where science steps in. So why do some wounds refuse to heal? Several factors play a role. Poor circulation, which deprives tissue of oxygen. Diabetes-related nerve damage, which reduces sensation and delays detection. Infection, which keeps the body in a constant inflammatory loop. Nutritional gaps or immune issues, which weaken the repair process. In these cases, simply cleaning and dressing the wound isn't enough. The body needs a biological jumpstart to restart healing. This is where tissue grafts come in. Unlike traditional dressings, grafts don't just protect the wound, they become part of the healing process. Tissue grafts are bioengineered materials, often derived from donated human tissue or advanced lab-grown substitutes. They contain a scaffold of collagen and extracellular matrix proteins, which mimic the natural structure of healthy skin. When applied to a chronic wound, this scaffold does 3 critical things. Kickstarts cellular activity. It signals the body's own cells, like fibroblasts and keratinocytes, to migrate into the wound and start repairing. Supports angiogenesis. That's the growth of new blood vessels, restoring oxygen and nutrient supply. Reduces inflammation. By creating a healthier wound environment, grafts help shift the body out of the inflammatory stage and back into active healing. Think of it as providing the missing blueprint the body needs to rebuild. Allografts are made of donated human tissue that's carefully processed to be safe and effective. Amniotic membrane grafts are derived from placental tissue, rich in growth factors that support regeneration. Each has unique benefits, but they all share the same goal: to create a healing environment where chronic wounds can finally close. The science of wound healing is complex, but innovations like tissue grafts are making recovery possible for more people every day. Healing isn't just about closing a wound, it's about restoring quality of life. Want to learn more about advanced wound care solutions? Visit specialtywoundcare.com to explore resources, treatments, and real innovations making a difference.